I'm Simon. You guys know me already. The people who are watching, probably not. I'm a data scientist, like specialized in reinforcement learning from Germany, and using RLlib, also contributing to it. I'm the founder of newway.ai, where I try to consult companies in the area of reinforcement learning. Yeah.
Artur?
I'm Artur, also from Germany, and I joined AnyScale as an intern 1 month ago, approximately. Yeah. But I've been around before, so I know my way around the library a little bit. And yeah, I hope I can answer Simon's question to you.
Thanks, and my name is Christy. I'm a dev advocate at AnyScale, and I'm here to help out. Okay, so I see on the Q&A that Simon had a question. Can you ask your question, Simon?
Yes, I'm happy to. I'm working right now on exploration and reinforcement learning, and especially there in an algorithm that's called random network distillation. And what it needs are two value heads, actually, because I have an extrinsic reward stream and an intrinsic reward stream. And from these two streams, I want to build up actually like two value heads, because one stream can be non-episodic, even if one stream is episodic. So right now I have not an idea how to implement that and where there are some hooks maybe in the RPs I can use. So I'm very excited what Artur may have figured out here.
Yeah, so we have a couple of such exploration modules in RLlib, and I think the first one that Sven built a couple of months ago was Curiosity, and then now Simon has an ongoing PR that is called Novelty. And when I read what you were writing, like the intrinsic rewards, I assumed that it has a lot to do with novel ID. Is that right, or is it another intrinsic reward signal that you're focusing on?
I'm now like focusing on the one from the distillation network as a novelty, but it's another algorithm novelty builds up on. So it's actually the same error that is taken as a intrinsic reward, and I just want to create from this reward stream a second value head, which I could use to later on combine, but that one is non-episodic and could have a non-discount factor.
And why would that be episodic? I mean, if you're talking about, I mean, there's a loss that you can. There's like a reward signal that you can use on a time step basis, right? And the loss you can calculate on a time step basis, right?
Yeah. So what I usually like have is like I have a extrinsic reward which the environment is giving me, right? That is usually stationary. And then I have the intrinsic reward, which is very non-stationary. And to combine these two together, but practice has at least shown that it makes sense to let the intrinsic reward run non-episodically, even if the environment is episodic. Therefore, I can't like take just the reward from the sample batch, add the intrinsic reward to it, and give it further on for training.
Okay, right. And you said there is another, there's supposed to be another value head, right? That is, I assume, meant to approximate the value that relates to the intrinsic reward signal.
Exactly. It's like playing the game without extrinsic rewards, just intrinsic, just doing actually the exploration game, right? And for this, the authors of the random network distillation paper use a second value head and show that this works quite well.
Okay, and you just train these in parallel and have, I assume, like an extra hyperparameter to tune, like a factor with which the second auxiliary reward signal is merged into the first one, and you would use the same optimizer, or how are you thinking about this?
You use at the end the same optimizer, but you actually like accumulate for the one value had the rewards non-episodically. So also the discount factor gets calculated differently in there.
How does it get calculated? Just out of curiosity.
So I try to read through their code, which is pretty hard because they take a naming which is fully unintuitive. What I see so far is they actually calculate the return, right? And try to actually like estimate the value had by creating a second network. The second network tries to fit the values towards the data which comes from this intrinsic reward stream.
Okay, but that sounds very episodic.
Yes, but only that the rewards are actually non-episodic.
Right. Okay. Anyway, so you have this additional reward signal, and you're sampling from the environment, and then your workers return batches, and that's like this is already kind of figured out, right? You get like at the end of your sampling step, you get a batch that has state action reward pairs, and then you calculate your intrinsic reward based on those, right?
Exactly.
Okay.
So I could add actually the intrinsic reward as an extra key in the sample batch, for example.
Yeah, right. So yeah, I mean, this is something that you would put into the post-process trajectory function, right? So our like these policies that you use in RLlib, all of them have this post-process trajectory method, and right, I think you probably know that, but whoever is viewing this video afterwards not. And we are actually reverting this right now. So in a couple of weeks, hopefully, or days even, you would be able to just inherit from any RLlib policy, and then Manny, and then write over this post-process trajectory function, right? And then they're just like in like very similar to how the exploration classes do it. There you would calculate another reward signal, right? So this is probably where we are on the same page, right?
Yeah,
have you done this already?
No, I've not done it. Maybe you can show some code, some source code where this is happening, for example, for PPO or for another algorithm that's implemented in RLlib.
Perfect, right? So let's have a look for, let's say, APPO policy. This has a post-process trajectory method implemented. So yeah, this essentially just overrides the post-process trajectory method of either dynamic or the Igor TF policy v2. But it would be obviously the same concept if you would inherit from this APPO TF policy, then you could just override this post-process trajectory method, and then do maybe something similar like what it's doing here, right? I mean, since you're dealing with another reward signal, then you could compute this reward signal on a batch basis here, and then possibly do something like the generalized advantage estimation. Right. So this is actually already how we build policies right now, or how we hope that users build upon our policies, right? With the classic inheritance model. So we have like a base policy here that is this is how you would do it, right? So you would take any policy class that you would want to add this additional intrinsic reward stream to. And just subclass it and write over post-process trajectory, like it's done here in A3C or here in APPO. Right. So then we would have intrinsic reward signal. Any questions so far? I think I've been talking for like a couple of minutes now.
Yeah. Say, if I would like to do that in such a way that I can plug in my exploration algorithm, like such that a user can automatically use RD, but just using it as exploration. How does it work like with all the algorithms in RLlib? Because as far as I see here, I should actually subclass this algorithm, right? And then override the post-process trajectory, which I would do if I want to write a custom algorithm. How I would do it if I use the exploration module, I do not yet understand.
So this is our exploration code, right? And I think, I mean, you've just written this PR, right? So somewhere here, you have a post-process trajectory method as well. And this is where you would calculate a loss, I guess, right?
Yeah, I could do that there. Yeah. How does it get to the policy at the end, such that it can train on it? Or how can I then add this to the other value head?
I mean, the exploration class, the exploration class's methods are called as soon as you switch on exploration, right? This is where it comes into play, and otherwise it's just switched off. And I mean, for what you're doing, can you re-explain what you're trying to do with a focus on, are you actually exploring? Is this like an exploratory intrinsic reward signal? Okay, well, then I think this loss should go into the exploration API. Yeah, so into an exploration class. So for the second, okay, so I think then we're on the same page in the sense that we've sampled our trajectories, right? We have post-processed them into including another reward signal. And then now the question is, okay, how do we get our new value estimates for the auxiliary reward signal and compute a loss for them and apply that one, and choose an optimizer and stuff like that, right?
Oh, yes, exactly.
Awesome. So I think what you would have to do for that is have a look at the Model V2 API, right? So this model that you're trying to build for this needs 3 heads, and that's not how models usually look in RLlib, obviously. So you would create your own model that has 3 heads, just like you would create any other custom model that you have in RLlib, just using the Model V2 API. And then you would hand that to your algorithm so that it constructs this model behind the scenes. And then in the exploration class, you would use this model to compute your auxiliary value estimates, and then add this loss term maybe to the ordinary value loss that you have, or however you want to do it from there on. But I think like if you're using the same optimizer, for example, then you would have to scale this signal, right?
If I could, can I ask one clarification question? Because I
I
feel like there's a small detail that's being spoken of differently. So I think what Simon is asking, and Simon, please correct me if I misunderstand, but I think he's asking, how is there a way to set this up for other end users of RLlib such that they don't have to specify like a custom model, right? They could just plug in his exploration with the models that RLlib provides.
Yeah, exactly. Yeah.
Okay.
Because because he certainly could make a custom model and stuff, but I think he's trying to ask, how could it be easy, streamlined for other users who may not, be able to go down that route?
Yeah, the hard part about this is that it's I think it wouldn't be applicable to all algorithms basically, because we have some algorithms that have a base model, and from what I understand, you would want to build upon this base model and add like a third head, right? And the way algorithms treat their models, or our policies treat their models, is not unified, right? So you can't. I'm thinking right now that you can't just plug this exploration API in and then use it anywhere really. I mean, I think you would have to you would have to provide a couple of different models actually to fit this exploration API. So.
Okay, so it's also that when the exploration class gets initialized, the policy is already initialized with the model. That has already been done then, right? So there's no possibility to maybe like in the initialization of the exploration class to somehow get access to the configuration that's building the model later on.
You have access to the configuration of this model inside the exploration class, right? Because that's part of the config, which. All right, no, there's the model actually, but
when I initialize the exploration, the model, is it already like initialized, or does the model gets initialized later?
Yeah, that's a good question. So the initialization happens afterwards.
All right. All right, maybe there's a way to somehow like take the model that has been either passed in by the user, or would be like used by RLlib by automatic referring.
Yeah, but you wanted to get around providing a custom model, right? So
true, but so that a user provides that. But if the exploration class gets the config and knows how the model should look like, that is, just take the model that has been passed in by the user, or take the model that RLlib would use and put a second value head on it and use that as a custom model, would then RLlib let produce that custom model, right?
Yeah, so I think what he's saying is you could add in the model instance, you could add a third head as a instance variable at some other point, right? And if the exploration module knew it was there, it could access it.
And how would this look for vanilla policy gradient? We have this this registry essentially, right? That you query with your model parameters, with your model settings, and then it gives you some model that basically just fits to your environment, and yeah, on whatever that gives you, we want to now build another value head, which is essentially like totally possible even like inside this module, but it's just that I think it would be dangerous to assume a certain structure here for kind of every algorithm that we have, right?
Yeah, gotcha.
I mean, but the steps that you would have to take here, I think, to summarize, if you would do this for yourself, like just to keep it a little more simple, if you would do this for yourself as first, and then I think after doing that, you could try to generalize to all algorithms. But I think a good step to start here would be to do this just for PPO, for example. Would be to calculate an initial reward signal in the post-process trajectory method, and then calculate an additional loss, and then figure out whether you want to use the same optimizer or another one, and apply this loss just on a batch basis, how just like you do it in the novelty algorithm, actually. Yeah.
For an example with a PPO, could you point me to the point where the PPO is actually calculating or training the value hat?
Yeah, so so we look at these files here. Where it's calculating the value hat, are you talking about the calculation of the loss, or where it's building the value hat?
The loss.
Yeah.
The loss.
So for PPO, that would just be like with this font size, there's not a lot of text that fits onto the screen here, but yeah, essentially that's the that would be the loss function, right? So since our transition to a like a policy subclassing scheme, this is how that looks here, and this is where you could possibly take some code from. Yeah. So wait, you were asking about the where the yeah, there you have the surrogate loss from the advantages, and this is essentially what you're using to train your value hat, right? It goes into your total loss there. Yeah.
And where are the extrinsic rewards used in the PPO algorithm?
The extrinsic rewards.
Yeah, so
like the ordinary rewards.
Just the rewards. Where are they used for calculation?
So I mean, the rewards are just parts of the batches that you sample, right? So every time you sample from a rollout worker, you get like a batch that has rewards as parts of them. And also actually advantages, because these advantages will be part of the post-processing step of the sample batch. So like this is something that you would normally do on rollout workers already, I think. And in the ordinary case, you would do this with a generalized advantage estimation. So this would have I mean, this is part of the policy. So there's this. I'm not sure whether we do post-process trajectory here on the rollout workers or on the driver process. But anyway, that's basically where it happens, right? So there's a sample batch incoming here with some rewards, and then you have an advantage, like an estimate of the advantage function. Yeah.
I just have to open the door. Sorry.
Yeah, go ahead. Right. Should we do like another introduction of Manny while Simon is gone, or should we just wait and you
Manny,
might cut out something, Christy?
Yeah, that sounds good. Manny, would you like to introduce yourself?
Yeah, I'm just say hi. My name is Manny. I'm, I don't know, longtime user of RLlib. Contribute when I have time. And I very much I've liked the library.
Yeah, Simon and Manny are actually, I think, our two most active community members. Like, I mean, where are we now? Do we have all the steps that you would need to finish this? Like, kind of. I mean, not to do this in a generalized way, but to do this for PPO, for example, right?
Yeah. So I definitely have a point like a post-process trajectory, right, where the value targets of PPO are calculated, as far as I understood you. So by this, I can look up how this is done in PPO, and I can just do that likewise for the intrinsic rewards.
Yeah, I mean, the only thing that you would that I hope you would have to change between these algorithms is the structure of the model, right? Because how you form this intrinsic reward signal is would stay the same.
Yeah, true. So it has to have a second value head that is trained with this different value targets, and then from this I could probably, like in the post-process trajectory of the exploration RP, then calculate further steps.
Absolutely, yeah. So you take this post-processing step here, and then differentiate between TensorFlow and PyTorch possibly, and then you would go into your exploration class and subclass from it, and then put something similar here, whatever kind of post-processing you want to do to the trajectory, and then you would need another model that has produces these value estimates for the intrinsic reward signal, and then you just put whatever that one spits out in your make it part of your loss, and that's it, I think.
Okay, so the model is actually custom that I have to produce.
I mean, in the first iteration of doing this, I would choose a custom. I would handcraft a model, to be honest, and then from there have a look at how other algorithms produce models, and if you can derive everything from it. But to be honest, I don't know how models typically look for each and every one of our algorithms, but I know that they have different structures. So yeah.
Yeah.
And possibly, if you're doing this and it works, then just ping Sven, and I suppose he will be happy to help to maybe have an idea to generalize this to all models. Yeah. Manny, you want to say something too?
Yeah, it's just I think it's a subtle thing, but so I don't know the state now, right? It used to be the case that at some point the sample batch was converted to a NumPy array. It may still be, I don't know. But that is only to put out a caution then for Simon that, if that still happens, you won't have a computation graph on the data stored in the sample batch. So this is, I think, where Artur keeps talking about, calculating the loss function, right? You'll have to rerun this stuff through the model in the loss function, probably to be able to have the computation graph to do your backwards pass. Yeah, it was just a subtle bookkeeping thing that's got me in the past, so I wanted to offer it as a beware, danger be here.
Yeah, sure. I mean, that's I think super helpful also for people watching. Who might be watching this.
Oh, I was just going to say we got 15 minutes left, so either we discuss this some more, or if Manny has a question.
So I'm good. I've got the information that helps me to go on.
Yeah, awesome. I don't have anything big. There was one thing I came across yesterday that I spent a little bit tracking down, and so I just thought I'd bring it up and see if it's something you guys would want to fix for or not. So it turns out that when you have grad clip enabled and the metrics are being stored in TensorBoard or JSON or whatever, the way it's done in PyTorch and the way it's done in TensorFlow are different. So the TensorFlow version is returning the grad norm after the clipping, and the Torch one is returning it before the clipping. So for example, the default grad norm, grad clip, right, in our RLlib, at least for A2C, which is I think what I was looking at that point, was 40. So in TensorFlow, it was always 40, but in PyTorch, it was like 2000. I went back and confirmed that after the clipping, if I recalculated the grad norm, it would be 40, but just the value store. And there's actually an old closed issue, number 4965, that reported this from like 2019.
Yeah, right. Okay. Well, thanks. It sounds more like you're reporting this instead of like asking a question. To be honest, I would have to look into this and.
So yeah. I don't have the ability to reopen an issue. I guess I could open a new issue and just link to the closed issue.
Can you ping the issue here in chat and I'll copy it?
4965. Yeah.
4965. Okay.
And that one is got stale or.
Yeah, it just got closed by the stale bot.
Yeah. Do you know where this happens actually? Where the grad norm clippings happen? So just to
it's
see.
in utils.
Okay, so I'll ping Richard then to reopen.
TF clip by norm. Is that the operation that you're talking about?
Mm-hmm.
Okay, yeah. I'm just like after this, I'm just gonna look up these two and see if they're specified to do something different and so on. Yeah, but thanks for.
Yeah, I'm gonna submit and if we have it reopened. I'm just checking to see if I can reopen it myself, and it looks like I can't. So, yeah, I think we can stop early if everybody's we got what we need right for now.
Yeah,
that's all I wanted to raise. Thank you so much.
Okay, thank you.
Yeah, thanks, guys.
Thanks, Artur.
Thank you, guys.
Thanks, Kirsty. Bye.
See you soon.
Thanks, Simon.